As Darren said, my name is Lauren. I'm a PhD student in the Department of Environment and Society, and I'm going to be moderating this morning. I'm excited to present our first keynote, Dr. Crystal Kolden. She is a pyrogeographer in the Forest, Rangeland, and Fire Sciences Department and the College of Resources at the University of Idaho, where she studies how humans can better live with fire.
So I am a professor at the University of Idaho. I'm also a former federal employee. I worked for several years with USGS, and prior to that, nearly a decade with US Forest Service. And I started out my career as a wildland firefighter. So I tend to come at questions from the perspective of how can my science directly address management needs. So this morning, I want to plant a seed in your mind about the power of fire refugia, a different way of looking at forest restoration and the metrics that we can use to measure that. So resilience in fire-adapted forests is, of course, a major topic these days. How do we actually build resilience in fire-adapted forests? And for some people, resilience is simply returning the regime that was there prior to European settlement, whether it's a stand replacing high severity fire, such as we see in the Northern Rockies, whether it allows trees that are adapted and have evolved to naturally respond and regenerate immediately post-fire. At the landscape scale, do resilient forests create mosaics when fire occurs? Maybe that's a definition of resilience. In mixed shrublands forests, maybe it's more about having shrubs that also immediately regenerate post-fire, such as we see in places like Southern California. Or maybe you're more interested in the habitat aspect, and a restored fire-adapted forest that is resilient is indicated by the species that are occupying that space that can only exist in restored resilient forests. So how do we manage for this forest resilience? Well, there's a lot of different ways that folks look at this, right? For many in the West, a big part of our management for forest resilience is treating those forests mechanically and reducing a lot of that fuels buildup that was produced from a century of fire exclusion. So maybe a resilient forest is one that has been treated, and that's our management approach. For many fire-adapted forests, the management approach is to add fire back to the system, right? And in some places, adding fire back is absolutely critical to restoring that regenerative, anyway, whatever the word is, right? It's early and I'm on Pacific time, so you'll forgive me a few slips of the tongue. So in places like Sequoia Kings Canyon in Yosemite National Forest, where we have giant sequoia groves, those are a species that need fire to regenerate, right? And a century of fire exclusion basically removed the nursery from these systems until fire was reintroduced through prescribed fire. And then there's also reintroduction of wildfire. Maybe that's a predominant management approach for restoring resilience in fire-adapted forests. So how do we measure our success in restoring fire if that's our definition of creating a fire-resilient forest? Well, there's a lot of metrics. If you're focusing on prescribed fire, which across much of the West, folks have been focusing on prescribed fire, right? We've got, 40 years of ecological literature that says we need more prescribed fire in the system. I can't tell you how many op-eds I've read in the last week, in the last several months, that I read pretty much every single fire season that say we've got to add more prescribed fire back in. Okay, so how are we doing on that? Well, this doesn't include this year's numbers. I think yesterday the prescribed fire total for the nation, as reported in the SIT report, which is slightly reliable, but maybe some variability, we're up to about 3 million acres for the year, right? But the problem, of course, is that almost all of that acreage occurs in the southeast. And if we look just at the west, we're pretty flat, right? We are not able to increase our prescribed fire acreage despite this vast amount of literature saying, we got to do this. Okay, well, but we're increasing the number of, or not the number of, but the amount of wildfire acreage. That's been made pretty clear in the literature. So how much of that is restoring fire to these fire-adapted forests? Because we've reduced the number of fires, right? So number of fires is actually declining over time. Area burned is increasing over time. I believe we're up to about 8.7 million acres for the year so far, with the Santa Ana's yet to come, okay? The problem is, if you're reducing the number of fires, but you're increasing the area, you of course are creating more and more megafires, right? And we don't have a good way of determining yet how much of that area, how much of that increase in area is actually producing forest resilience versus not. And some preliminary work that I've been doing with the Nature Conservancy in the Northwest suggests that we are not actually restoring low severity fire to forests that are adapted to low severity fire. That in fact, the small amount of fire that most of our low severity fire forests are getting is high severity fire, far above what we would expect based on the adaptation characteristics in the pre-European settlement regime for those systems, okay? So problematic to look just at fire area burned. All right. So why are we coming up short trying to restore forests with fire? Well, it's a challenge. It's an impossible task in many ways because we have this whole climate change thing that is making it incredibly difficult in terms of conditions, in terms of constantly changing responses from the landscape. We have things like bark beetles, invasive species. Oh, and then there's that little wooey thing, that's a problem. And apparently now, even if you live in the urban area and not just in the wooey, you also can find yourself at high risk for fire. We have changing land use patterns, changing policy and management. You know, the agencies come out with new policies all the time, and the discontinuity of a lot of those policies means that you as managers are constantly having to adjust your game, right? And really we have a problem with non-stationarity. How do we restore something that we don't have the conditions for that created those forests 200, 300, 500 years ago? We don't have those conditions anymore. We can't go back. And at the landscape scale, it means that it's almost impossible to actually try and restore huge forests equating to hundreds of millions of acres of landscape, right? Almost impossible. So I would like to suggest that there's something else that we can focus on, not instead of, but as a metric that we can look at that is much smaller in scale and yet has a huge impact in terms of forest resilience, and that is fire refugia, islands that resist fire. This is a photo from Canada that I took this summer, and of course this is a high severity fire regime. This is in the Canadian Rockies, in a place that about a week after I took this picture, they closed the highway because it was burning yet again. It stayed closed for almost 2 months. And even in this high severity forest, or high severity fire, little pockets of green. I started working on fire refugia about 10 years ago, and it was in part because I kept going out to these fire scars. I was looking at satellite remote sensing of burn severity at the time, and people would tell me, oh, this fire was terrible, we lost everything, it's a disaster. Common rhetoric, right? And then I'd go out and I'd say, hey, look, there's all this green stuff. This is gonna reseed the fire area. People are like, oh, I didn't even see that. Well, those refugia are overlooked, but they're really, really critical. So what are fire refugia? They're not well defined. There's no one accepted definition, but in general, they are places that resist fire, right? They persist through fire in a very functional sort of way, right? And they can be very small, a few trees comprising a patch, right? A lot of times they happen in drainages, or we have a little bit cooler, wetter conditions. And even in very large, highly destructive fires, like the 2013 Rim Fire in California, you know, what most people focus on is this giant amount of red, high severity, stand replacing fire. And I look at this and say, hey, look at all this green. Look at all of these fire refugia. Why is persistence so important? Well, there's a lot of reasons it's really important, right? One is that, hey, during the fire, that's where the fauna are going to hang out and survive, right? And even in the post-fire period, when it's moonscape around them, that's where they're hanging out, right? And these pockets of persistence, these refugia, right, those are creating microclimates that are so critical to that post-fire regeneration process because they provide shade. They provide that slightly cooler area that allows for some of the reseeding to take place for certain species that require that, right? And of course, they're providing that seed source. In recent years, I've also started to realize that refugia naturally occur and are an excellent template for what we would like our communities to be. Because we want our communities to be refugia. We want our homes to be refugia. And we've got nature's template for how to make these places fire resistant, but we don't know enough yet to apply that template. When we started working on this, part of the thing that we wanted to ask was, okay, so if the climate is changing and it's getting hotter and drier during our summers, warmer during our winters with faster snowmelt in the spring, are these refugia going to be more vulnerable? I was hearing stories from my friends that were still in fire in Southern California about how places, particularly in riparian areas that they had never seen burn in their 35-year career, they were starting to see those places burn. And we thought, okay, well, this is a really critical thing to look at because in a process of forest disturbance and then recovery and then disturbance and then recovery, right? These refugia are critical because they're these remnants. And oftentimes in a resilient, healthy forest, right, those are diffusing seed sources, right? And they're helping to create this recovered forest. Sometimes, though, they become relics of the past, right? And they become vulnerable to subsequent disturbances. And if you lose those vulnerable and relic refugia, then that potential seed source, that reminder of what was there and what had evolved to be in that location is gone. So these are a template for forest recovery. They're a template for we want our communities to be, which is fire resistant. But there's a few things we need to figure out before we can start applying that template, before we can start using this for management. First, we need to understand fire refugia. And specifically, there's a couple things we want to look at. First of all, are these a bottom-up or a top-down process, right? What controls formation of fire refugia during a fire event? Because if it's a top-down process, if it's entirely controlled by large-scale climatic conditions, then we don't have a lot of control over it. But if it's a bottom-up process, at the landscape scale, at small scales, then we have some say in the matter. And we also need to know if this is a different control across systems, because we know for fire occurrence, for area burned, that what controls that process is very different across different ecoregions. So we need to understand if that difference also is there for fire refugia. And so first we wanted to ask something about the relationship between fire refugia and this trend that we're seeing in wildfire in general, right? Because of course, you know, this graphic has not been updated, but fires are getting bigger, right? We are seeing more area burned across the US, particularly in the western US, right? And we're seeing longer fire seasons, we're seeing drier, warmer conditions. We're seeing doom and gloom in general, right? And some work that was done early trying to answer this question of are fires becoming more severe? Well, at least for a couple places in California, there might have been some evidence that fires were becoming more severe. And since this paper, there's been some other work that's looked at severity across the West and said, well, maybe they're not actually becoming more severe, right? But severity is also poorly defined. So it's a really tough question to answer. But it's an important one to answer because here's the thing. Most fires, if you look at severity distributions, they are normally distributed, okay? You have a little bit of low severity, a little bit of low severity, a little bit of really high severity, but the vast majority of severity is kind of in the middle. It's mostly normally distributed. But one of the theories is that under climate change, that severity distribution is going to change, but we don't know how. We don't know if it's just all going to shift to the right, because if that happens, all of our super low severity and unburned stuff completely falls out. Or it could just change the shape of the distribution, or we could end up with a different type of distribution going from normal to bimodal or other, right? So we don't really know what the relationship is between severity and refugia. And it's really critical to understand that. And it's not just important to understand the distribution of severity, but also to look at how refugia occur in patches across the landscape, right? Because it's not just about how much unburned area or fire refugia area there is, it's about what that area looks like in a pattern across the landscape. How many patches are there? How big are those patches? How close are they, or far apart are they? Because one of the things that we could potentially see is that patches are changing size. If they're getting bigger, but they're further apart, that means that fauna have further to go to get between refugia and that post-fire landscape, right? Or maybe they're getting smaller and more dense, or maybe they're getting smaller and not more dense, and we're losing some of our unburned area, right? And these are all really critical things to look at. And I finally found a great example of why these are critical to look at, not from the fire world, but from a friend of mine who happens to work in desert lizards. Okay, and they did a study in White Sands, New Mexico a few years ago that was published in PNAS last year, and it looked at why is this patch stuff important? And they were looking at ectotherms, so these little lizards that thermoregulate, right? And they basically said, okay, these are creatures that have evolved to be able to move a certain distance in the super hot sun and still be able to function critically, right? And then they have to get back into the shade to cool off again. And so they put out this whole crazy array of different patch configurations. All of this is the same amount of shade, it's just different configurations. And what they figured out was the little lizards need lots of patches that are not very far apart. Otherwise, they start getting too hot and their body begins to shut down all the time and they're in a constant state of stress. So I'm going to assume that we have some similar types of activities or some similar types of biological responses in fauna and fire adapted ecosystems, right? I don't know what those are. Nobody's done the work on this yet, but I'm going to assume that they're there. And so the patches are really important. Okay, so we started out looking at this several years ago in just 3 national parks where we had some really good data sets, and we are quantifying these fire refugia from remotely sensed data. And we basically found a couple of things that surprised us early on. First of all, that refugia, or the proportion unburned across a fire, are actually pretty well related to fire severity. So as you increase severity of fire, you see a lower proportion of unburned area. What was also interesting, however, was that the relationship between proportion unburned and the size of the fire was not a good relationship. This is great because as we see these larger and larger megafires, right, that would suggest to us that we may not lose that unburned proportion, right? But these are 2 very different results that made us say, okay, maybe we need a bigger data set. We also found, when we looked at edge distances, that most of the burned area is much closer to an unburned patch in the interior of the fire than to an unburned edge. And this is really critical for that diffusion piece, right? Because if you're expecting that all of your burned area is going to get reseeded from outside the burned area. What this is suggesting is that's not true. Most of it is likely going to get reseeded from inside the burned area, right? This is also important for management because it suggests that we should not be burning unburned islands. I'll come back to that in a minute. So we decided we need a bigger data set, and we set out to map all fire refugia, and we made it the most conservative definition. We said unburned islands, for 30 years worth of fire in the Inland Northwest. And we ended up with 7,500 fires and about 700,000 unburned islands. And when we looked at whether or not there was a trend in the unburned proportion, if we looked at the fire area during the same time, which is these columns, we see these big fire years and overall an increasing trend in burned area. But there's no trend in the unburned proportion. So even as fires are getting bigger, right, a larger proportion or a larger area is being unburned still within those fires. So it's maintaining that proportion. So that's a good thing. And then, of course, we have to stratify by ecoregion because we've got really different ecosystems. We didn't just look at forests, we also looked at rangelands. And even when we stratify by ecoregion, there's no increase or decrease in the unburned proportion. This is good. Then we said, all right, is climate a controller of this? And what we basically found is that we have a really high N, because, you know, when you've got 7,000 fires and 700,000 unburned islands, you have a really high N. So yeah, some of our results are significant, but these are R values, not R squared values. And that indicates to me that this is not a very strong relationship at all. And that was for baseline climatology, and we said, okay, well, that's just baseline climatology. Let's also look, of course, at interannual variability. What about those drought years? And again, yeah, we've got some significant results where these little X's are, but overwhelmingly, these are low R values. This is not a very good relationship. Okay, and part of it, of course, is that there's a scale mismatch, but what we looked at this as is some pretty good support for this idea that this is not being controlled top-down. And some other work that's being done by colleagues at RMRS and Oregon State and up in Canada is suggesting that topography is an excellent controller of fire refugia and some of the Canadian fires they looked at. Okay. So an important caveat is that fire refugia here are defined by fire effects, not by the function of that refugia. We were using satellite data. So we were simply looking at where are the places that did not burn under the most conservative definition of fire refugia. And we found that climatic variables are generally a pretty poor predictor of fire refugia across this giant region. And that suggests that local small-scale drivers are a likely key to prediction. Because, and this is important, because bottom-up determinants suggest that we can have a lot of impact through our management actions. Okay? So what can we do? Well, okay, our data set is giant. And we have not yet gone through and tried to actually attribute these unburned islands, these fire refugia. Some of them, I mean, because we did a lot of field work associated with this, so some of them we know are places that there's just simply not any vegetation. Giant talus slopes, right? Big river sandbars and rock bars and things like that. Some of them are places that are not going to be able to support certain types of fauna. Right, wet meadows are only going to be able to support certain creatures, not others, right? But we need to come up with a way to actually try and attribute these. My colleague, Meg Krawczyk at Oregon State, is currently working on a taxonomy of fire refugia so that we can combine our two approaches and actually try and attribute these things and say, okay, this is not simply a refugia, it's a refugia that has these ecosystem functions, A, B, and C. Right, and is this type of habitat or whatnot. And once we get that done, we'll be able to actually go in and prioritize refugia. Because the thing is, we can't save them all. right? So some key components that we need to look at are things like, where do fire and climate refugia intersect? Because one of the big things in the conservation community right now is, let's find the climate refugia. We have a changing climate. We know that a lot of these places that are currently habitat for species of interest X, not going to be viable habitat in 20, 50 years, right? And so there's a large community of people that are working on climate refugia and saying, well, look, here's a great climate refugia. Let's make this a conservation site or a conservation priority, right? Here's another climate refugia. Let's make this a conservation priority. Well, that's all grand and fine until it burns. So part of what we want to try and do is understand, all right, where are there naturally places that there's an intersection of climate and fire refugia? Where are the biodiversity hotspots, right? This also plays into management for conservation needs. And where are the places that management can actually take the most impactful actions, right? Because there's a lot of places that you can't do a lot of work. Wilderness areas, you're not going to be able to do a lot of active management in those places to try and support fire refugia through the next fire, right? But places that are closer to roads, easily accessible, places that are not mixed property. Of course, a ton of these fire refugia occurred on private land. Nothing we can do there, unless you can work in sort of a mixed conservation approach with different partners, right? But there are a lot of places that are on federal lands that we can take more meaningful management impacts, impactful actions, right? And then the other key thing is that where are the refugia that are best predicted by bottom-up predictors, okay? Because in some places, we may not have a good idea of why there's a fire refugia there. Maybe it was a wind shift in the fire, and they just got lucky, right? Otherwise, it would have burned. But maybe it's something really tangible, right? Like a spring supporting a wet meadow, right? Like a stand of trees that has created its own nice, shady microclimate. And if we continue to support that, right, through management actions, then it will continue maintaining that nice, shady microclimate. So we want to find the place that we can have the most impactful management actions because those fire refugia are best predicted by bottom-up agents. So how do we actually apply these management actions, right? It's the same stuff. Prescribe fire, fuel treatments. You know, there's been a lot of work on fuel treatments, and the agencies spend gazillions of dollars on fuel treatments. And we have a lot of great local success stories. We also have a fair amount of science that says, yeah, so when we look at these things across really big landscapes, what we find is that the vast majority of time, fires and fuels treatments don't intersect very often, right? That doesn't mean that we should just stop doing them, but it also means that we have to think about how we strategically place them. And of course, strategic placement of fuel treatments, right? Or in the Finney terminology, it's those splats, right? This is the subject of enormous amounts of research right now, trying to figure out where to place these things. Well, I would submit that one of the places that we can really focus fuels treatments for high impact is around fire refugia. We also need to think about fire refugia in a decision support framework that's of course used by fire personnel. Because one of the things that there's just no indication of where these things are across the landscape. Fire starts, we don't even know where to go, right? So having this integrated decision support tools like WFDIS, addressing fire refugia in the post-fire rehab period. You know, I was on a fire crew, and I know exactly what happens when there's an active fire going. Anywhere near the perimeter of that fire, if there is an unburned island of vegetation, firefighters don't see an unburned island or a fire refugia. They see a pocket of fuel that could potentially explode, throw embers across the line, and they lose their containment line, right? So we have this established procedure by which we burn out a lot of our unburned islands during fire suppression with the goal of trying to mitigate this extension of the fire, keep it from blowing up again, right? And overcoming this is a major challenge given perceptions about wildfire. And a great example of this is from the old 2002 Biscuit Fire scar. So you may recall that the Biscuit Fire of '02 was the 500,000-acre behemoth that burned for, I don't know, 4 or 5 months across the California-Oregon border, right? So there's California, Oregon, there's the Pacific Ocean out there, and over here is I-5, right? And so there's this huge fire scar. Right smack in the middle of it was a giant unburned island. Lots and lots of unburned up here in the northern portion of the fire scar, right? And this is generally the outline of the scar. And in 2015, they had a fire start right in the middle of the big unburned island. Now, when I first saw this fire show up on the SIT report and started looking at the news stuff, I was like, oh, sweet. They've got a fire that they can just let go because they've got a natural fire break. It's called a giant fire that burned 13 years prior. That's not the way the locals looked at it. The immediate response from much of the local communities and the managers was, why didn't they burn this thing out in 2002? How could they have possibly left all that fuel standing? And in reality, yeah, there's a little bit of moderate to high severity, but most of this 2015 fire burned at relatively low severity. Oops. And then, of course, this year, still burning right now, is the Chetco Bar fire. That number, I think, is a little bit higher now, needs to be updated. But the Chetco Bar fire is up here in the northwest portion. It burned predominantly in these unburned areas. But as it started to move into the old Biscuit Fire scar, it hit a lot of these fire refugia pockets, and local communities again threw a fit. How on earth could you have left all this fuel there? And I read reports coming out of the fire management agencies about all the dangers of having this intermix of snags from the '02 fire and then unburned islands left within that, and how that was producing all these injuries and whatnot. And I thought, well, that's one way to look at it. Or you could say, hey, this is great that this burned into this fire scar, and it's, at some point in the near future, it's going to run out of fuel, and not send people into really dangerous locations. But I'm in the minority, of course, because I don't live there. Okay, so in summary, restoring fire to fire-adapted forests it's an uphill battle, right? There's a lot of landscape that needs to be restored. And the reality is that we're not going to be able to suppress fire. It amazes me every fire season that we see. Again, renewed calls for let's go ahead and suppress all the fires. Didn't work last time, not going to work this time, right? So one thing that we can do and potentially have some success at on a much smaller scale is focus on supporting the formation and management, continued management of fire refugia, right? They form naturally. And to do that, we have to try and understand them better. Inventory and attribute existing fire refugia, prioritize refugia based on these attributes, develop management strategies specifically to support refugia, right? And really, a really key piece is maintain them during fire suppression. And if we can work through a lot of those details, I believe that we can apply what we've learned to communities and make our communities much more fire resistant. Thank you very much.
We have about 7 minutes for questions.
Tucker. Yeah, so the question is, I talked about management actions to support fire refugia, and what about the role of prescribed fire in those management actions? Am I interpreting correctly? So yeah, prescribed fire is absolutely one of the most powerful tools we have to support fire refugia. In our studies, we've been defining refugia the most conservative way, which is as completely unburned islands. But we also know that some of those unburned islands actually had low severity fire in them, and that it's simply a challenge of the satellite to be able to see through dense canopies and look at forest floors, right, which they really can't do. They're not designed to do, especially for spectral remote sensing. So prescribed fire is one of those critical actions, right? So it's killing multiple birds with one stone, or one drip torch, as it were, right? And that's a way of removing a lot of those fuels. Again, prescribed fire is, we're not increasing the amount, and it's hard to do. And most of the time, prescribed fires are relatively small. I was down in northern Arizona a couple weeks ago, and October and on the Mogollon Rim that's prescribed fire season, and they have a heck of a prescribed fire program down in Arizona, right? Region 3, the Forest Service, is one of the most aggressive burners in the West. A really big prescribed burn for them is 600 acres. When you've got fires like the Wallow Fire or the Horseshoe 2 fire that burned a few years ago in Arizona, burning 500,000 acres in a week or two, 600 acre prescribed fire isn't going to do much at a really big landscape scale. But a 600 acre prescribed fire can do a lot to preserve and maintain critical fire refugia. Yeah. Yeah, so the question was, to what extent has the temporal dynamism of refugia been addressed in the research, right? And the answer is not much at all, right? Because most of that work that's been done on fire at centurial or longer timescales, of course, comes out of tree ring chronologies, and most dendro folks I know are not interested in the trees that don't have fire scars. They're only interested in the trees that do have fire scars, right? I will say that there's a fantastic paper by Camp et al. In 1997 in the Forest Ecology Management Journal, and that paper is one of the few that has looked at refugia over a longer time scale, and they were looking at it specifically following the 93 spotted owl decision in the Northwest, and they wanted to go out and look for locations on the Wenatchee National Forest that were potentially refugia for spotted owls, and so they looked at tree ages and fire scars and community assemblages and identified some fire refugia. Amusingly, or not amusingly, coincidentally and fantastic for science, their sites burned in 2012 in the Table Mountain Fire. And I had a grad student that went out and relocated their plots and asked that exact question. How many of these refugia that were identified in the mid-90s from previous fires actually persisted through this 2012 fire? When we use the most conservative definition of refugia, purely unburned, 1 out of 122 sites didn't burn. That's a really conservative definition of refugia, and it's the only study that I know of that's gone back and looked at sites that specifically identified as refugia. So there is a huge amount of research that is needed in this arena to understand how many refugia currently on the landscape are ephemeral, right? Just this time they happen to be refugia, next time they're likely to burn, last time they burned, right? Versus persistent or even permanent fire refugia, because identifying those persistent and permanent ones, right, that's the really critical piece, because those are the ones that we want to try and copy. So great question. Yeah, Mike.
I was wondering about the scale of the refugia. I don't know if you said it was mostly defined. How big and small? What is the range of a suitable refugia?
So the question is size related. What's a suitable range of size for refugia? And the answer is it depends on your definition of refugia based on your species of interest, right? And we just finished a synthesis of this exact. What is the range of things that people have defined as refugia? And sometimes they're really small, only a few trees. And other people say, no, they really need to be a lot bigger so that they're really containing all of those landscape scale ecosystem processes. In our study, this is satellite data, and our minimum refugia size in our giant data set was 2 Landsat pixels, which is a 30 meter by 60 meter area, right? So we didn't get all those little dinky patches that were left over, but may actually serve refugia for certain species. Lots of work needed. Thank you.